And we're recording. This is live. All right. So I'm going to make a new sheet. I'm going to make it some other more sensible place, like ecology lecture. All right. So then I'm going to make a new sheet. Okay. And then we're going to have the scenario as one piece of data. Nope. Scenario. And then we're going to have the number of generations, so gens. The scenarios are default, more offspring, and what's the other one? Greater variance. Greater variance. Okay, and then I'm just going to copy this and paste it 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 times. Okay. So then generations, let's just go down the line. Read me your... and this is another thing I wanted to point out. If you feel like you guys made errors at any point in your numerical simulation, so you feel like a particular piece of data that you might read off is junk, just say so and we'll leave it as an omitted piece of data. Okay, so go. What is your generations for default? 3. And then more, when you had more offspring?
9.
This is the one I looked at. The reason I said that, is that right? That's what you got, huh?
That's what
and you guys feel confident? Okay. Sometimes you do. There's that, like, it's not, you could flip a coin 100 times and get heads every time. Okay, next one? 4. Okay, next guy. So let's make this fast. Go.
7.
Yep.
3.
Yep.
4.
Okay. Then going across, Brittany.
5.
Yep.
6.
Okay. All the way down.
11. 3 and 3.
Okay. Starting over here.
6. 5. 4.
6, 5, 4. Okay. You guys.
5. 5. 4.
5, 5, 4. There.
9. 8. 5.
9, 8, 5. Okay. Back here. 8, 4, 3. Across.
6. 4. 3.
6, 4, 3. Okay. Back there. Matt. 7, 3, 2. Okay. You guys, Paulina? 5, 6, 4. All the way back. 7, 6, 8. 7, 4, 3. Okay, great. So now I've got these guys in here. I'm going to call this SP 2018 Artificial Selection or something like that. Okay, great. Now I'm going to download this as a CSV file. R can open all kinds of stuff. I'm going to show this in the Finder. Okay, that's where it's at. I'm going to move it to Ecology Lecture, Spring 2018. Okay, so now that file exists in this folder. Now I'm going to go over to R, and we'll make this as large as it can be. I need to find a way to point to that file, because that's the file that I want to get in there. And the trick for that is file.choose, parentheses. And then that opens up a little dialog box, and I can go over to that very file, select it, and it gives me the file path for that. I'm going to copy it, and I'm going to start a new script. And in my scripts, and in your scripts, always keep things very organized. Do all your data frame stuff at the top, all of your analyses at the bottom. So I'm going to load in this data frame as art.df. That's just the name I'm making up. It could have been bananas or bongos, but I chose art.df for artificial selection. And then I'm going to do read.csv, and then I'm going to paste in that file path. And now, it's a big long file path. When I hit run, look, I've got this data frame in there, and if I click on it, I can look at it. It's just the data that we just entered. So that's cool. Okay. Questions so far? I mean, some of this might not make sense, but eventually when you come back to this recording, it should all ultimately make sense. Okay, so now I want to look at those data, and so the way I'm going to do that is with plot, and I'm going to choose art.df, and then I do a $ to pick off one of those columns, and now I want my response, so that's the number of generations. I do a little tilde, and then I'm going to do my predictor, art.df, and I do a $ to pick off the scenario. And now if I hit run, I should have a nice plot. There it is. So let's scoot this over a little bit. Right, so just looking at this, this is the median. It looks like the default took the largest number of generations. With greater variation, we had fewer generations, and with more offspring, we had sort of in between. The thing that bothers me about these box plots is they hide the fact that there's actually little data points in there. So always sort of keep that in mind. Like all right, I'm going to just do it really quick. I'm going to make a dummy variable and do this one more time. So default is 1, greater var is 2, and more offspring is 3. Those are going to be my dummy variables. And then if I plot it, it's going to think that I have quantitative data. So if I go over here, then I'm going to insert a column to the, there we go. This is going to be scenario dummy. So default was 1, more offspring was 3, and greater variation was 2, right? Then copy that, paste all the way down here. Good. Do this again, download as CSV file, great. Go back to my Finder, move it again. Oh wait, this is it. Oh, if I go back over here, then I get the convenient little show me in the Finder. There it is. I'm going to drag it over here. It's going to ask me if I want to replace it. I'm going to say replace it. Yeah, overwrite that thing. And now watch, when I come back to R and I run this line of code again, it's going to overwrite that data frame with my new column in there. So let's run that. Cool. Let's make sure that that actually worked. Click on this again, and look, my dummy variable is now in there. Cool. Okay. So I can make this plot, which we've already seen. I can also make my dummy plot. So plot art.df $gen, same response, but now I'm going to use my dummy. So art.df $scenario dummy, and if I run this, then you can see that there's actually data points behind that. So you've got all these data points. These ones are lower, these ones are a little bit bigger. And then if you look at the box plot, the box plot is really summarizing all of that stuff. Okay, so those are our data. And now the question is, there's variation. We heard they had the crazy 9 over there. The question is there actually evidence that there's a real difference between these different scenarios? And so we use, in this case, we have a qualitative predictor and we have a quantitative response. And so the statistical test we use is ANOVA, as you guys will learn. So I'm going to come over here. I am going to type a new object name called my output, whatever. I'm going to use the ANOVA function, and I am going to copy this because it's the exact same coding. And now I'm going to run that, and now I have this object. I'll just insert here that normally you would want to check your assumptions. I could check my assumptions really quick, but you guys don't know what that is yet. So I'm not going to just check my assumptions, but you should check your assumptions. I'm just going to jump to the fun part, call summary on this thing, my output. And now we get to see, is the p-value statistically significant? Oh, it's so far down there you guys can't see it. Oh, and now it's, here, let me just get that up to the top. Right, so this is asking, what is the probability of obtaining these data if in fact there's no real difference between these scenarios? And this is saying that if we make that assumption, there's only a 1 in 100 chance of obtaining these data. So that's good evidence that there really is a difference between these scenarios. and because we have three different qualitative variables, we can ask, this is just saying there's some difference. We could say, is there a specific difference between any of these? You do a post hoc test to get at that. And so I'm going to just do a quick post hoc test in my script. That is Tukey, not turkey, HSD, and I call that on my output. And we'll run that, and then we'll get some more stuff. All right, so let's do that. Let me hit return to get this up to the top. So this is the probability of obtaining differences between these, and the only one that's significant is between greater variation and the default. So there's a significant difference between these two guys, but not a significant difference between those, and not a significant difference between those. So what does this say? If you wanted to increase your artificial breeding program, the best thing you could possibly do, according to this very limited data set, is increase the variation of the offspring, because then you have a greater chance of getting those large numbers for your large-footed whatevers or your faster lions or whatever your creature was that you're trying to breed. Cool. So we just ran models, gathered the data, analyzed the data. That's kind of what I want to say about that. Questions? Okay, fair enough. If questions come up later on today, later on next week, later on next month, 2 months from now, feel free to ask them. Okay, and I will